Okay, good evening, my dear students. Welcome to Gradeup, India's biggest e-learning platform. So, how are you all? I hope so. You're healthy and your preparation is up to the mark because it's very less number of days. Those who are going for GATE 2020, and how about the previous classes? I hope so. You understood the basic concepts of radiation because we have covered some of the basic terminologies related to the radiation topic. Clear? So any doubt? Very welcome, Mohammed Yusuf. So how are you? I hope so. Your preparations and your health is the topmost priority. Please be safe and be healthy so that you can give more emphasis on the concepts, because if you are healthy, then only your brain will be working and then only your concept will be built up. So very good evening, Nityanand. Very good evening, Monisha. So enjoying the sessions? And do let me know if you're having any doubt, because I have seen many of the students, they don't ask doubts. So it's better you'd ask the doubt directly in the live session, and I can give you the solution and the concept behind that solution in the live session only, whenever we get the time. Okay. So very good evening. So till this point of time, we have covered the laws of radiation. We have covered the different terminologies, definitions. We have talked about the MSE powers, the emissivity, different bodies, gray body, black body, white body, absorptivity, transmissivity, reflectivity. These were some basic terminologies which we have been studying for the last two sessions. Okay, I welcome you all again to this live session on radiation network. So let us begin. This is the most important topic, and in today's session I will be taking some basic questions, sample questions, so that you can apply how to use your concept and how can apply your concept in the problems. Okay, in the end of this session I'll be taking up some of the problems based on radiation network, because radiation network is one of the most important topic from radiation heat transfer topic. So let us begin this session. This is about myself. My name is Sooraj. I've completed the M.Tech and have more than 5 years of teaching. Clear? So this is my expertise subjects: mechanics, thermal applied, heat transfer, industrial engineering. Like many of the students know me, I've taken the classes. So let us start the topic. Shape factor, you might have come across these few terminologies: shape factor, view factor, configuration factor. Basically both the three identities are the same thing. Clear? All the three identities are the same thing. So can you tell me what is the meaning of shape factor or configuration factor, view factor? What do you understand by this term shape factor? If you know, just respond. If you don't know, just at least try from your side so that I can get to know like how much you know about this topic. So what do you mean by shape factor? Quickly, Monisha, Nityanand, Mohammed, Narendra, what do you mean by shape factor? Yes. Shape factor is basically, let me take an example for you. Fine. Example is, for example, we are having one plate, we are having a plate, we are having a second plate. Okay, these are two plates. From plate 1, we are having some, for example, 100 units is being emitted from plate 1, and out of this 100, let us suppose only 30 units is reaching plate 2. Because there can be chances the radiation won't be reaching the plate 2. This is plate 1. Sorry, this is plate 1. This is plate 2. So there are chances like plate 2 won't be able to receive all the 100 units to plate 2. So I can say the fraction of emission which is leaving surface 1 and reaching surface 2 will be equal to 30 by 100, which is 0.3. That means out of 100, only 30 units is reaching surface 2, or we can say 30% of the radiation is reaching surface 2. Very good, Ravi Teja. Exactly, it's the amount of radiation transferred to the other surface, or we can say the fraction of radiation which is leaving surface 1 and reaching surface 2. Similar thing is also applicable for surface 2. For example, from surface 2, 50 units is being emitted, and out of 50, 40 units is being reached. So can you tell me what will be F21? If I say 50 units is leaving surface 2 and out of 50, 40 is reaching surface 1. So can you tell me what is the shape factor from 2 to 1? This is the notation because we are going from plate 2 to plate 1. So what will be the F21? It will be 40 by 50, which is 0.8. Clear? Which will be 0.8. 0.8, very good. Sharmila, it should be 0.8, not 0.1. It will be 40 by 50. Clear? This is the basic definition because in radiation, you should be knowing the basic terminologies. Shape factor is the most important terminology. In the shape factor, there are two laws which you need to understand. The first theorem is Reciprocity Theorem. Reciprocity Theorem. This is the first theorem which you need to understand. Why 0.8? It's very easy because out of 50, only 40 is reaching surface 1. So it will be directly 40 by 50. Fine, which is 0.8. Clear, Saurabh? Now, next is reciprocity theorem. There are two rules or two theorems associated with this shape factor. Reciprocity theorem, it basically states that if there are two surfaces, any surface, plane surface, cylindrical surface, or we can say spherical surface, the shape factor of body 1 to body 2 into the area 1 is equal to the shape factor of body 2 with respect to 1 into area 2. This is reciprocity theorem. Very important. We'll be solving some numerical based on this reciprocity theorem today in this session. Clear? The next, we can say the next theorem or next rule is summation rule. Summation rule. Summation rule, it basically states that if we are having more number of surface, for example, we are having a surface like this 1, 2, 3, 4, we are having n surface. So according to summation rule, what it says that the shape factor with respect to 1 plus f12 plus f13 till f1n, the summation of all the shape factor with respect to the only one surface will be equal to 1. This is summation rule. If I am taking n number of surface, if I add what is the fraction of radiation which is leaving surface 1 and reaching all the surface, the summation of that should be equal to 1. This is the two rules or two theorems which is very, very important if you are talking about a shape factor. Clear? Understood? Let us take some examples. On the basis of this example, we can say, for example, if you are having a flat surface, now respond to me quickly. If you are having a flat surface, so can you tell me what will be the shape factor of surface 1 with respect to its own surface? I am talking about this. What will be F11? Quickly tell me. What will be F11? If you are able to, we'll be taking few examples in this live session. F11. Very good, Ravi Teja. I've got one answer from Ravi Teja. What about the rest? Please respond quickly so that we can deal many examples. Suman, Nagaraju, very good. It is 0. Why it is 0? Because none of the emission will be reaching its own surface. Clear? None of the emission will be reaching its own surface. So basically it is F11 equal to 0. Let us take, this is surface 1. It's a concave surface. So for this also, can you tell me what will be F11? What will be F11? Quickly respond. If you are taking a concave surface, what will be the shape factor of body 1 with respect to its own surface? It will be again equal to 0. Why 0? Because it will never ever reach its own surface. If you talk about the flat surface, if you talk about the concave surface, never ever it will reach its own surface. Exactly, those who are responding it's 0, it's all correct. Suman, it will be 0, not 1. It will be 0 because none of the surface will be reaching its own surface. This is a concave surface. Clear? Understood? Let us take one more example. This is convex. This is convex surface. Clear? Take concave surface. This one. I'm taking this surface as 1. So can you tell me what will be F12, F11 equal to? What will be F11? Not equal to 0. Very good. I'm taking 3 options. Option A is equal to 0. Option B is F11 equal not equal to, or we can say less than 0. Yes, there are 2 options. Option A is equal to 0 for this surface, and option B is F11 equal to 0. So can you tell me which is correct? A option or B option? I'm taking 2 probability. F11 equal to 0 and F11 is less than 0. So which is correct? Very good, Rushikesh, Sharmila, very good. Aryan Sharma, very good. So option B is correct. Why? Because some of the radiation, if I take, some of the radiation will definitely reach its own surface. So it will be F11 is less than 0. Understood? Very good. Let us take a hemispherical body. This the bottom flat surface is surface 1. The dome surface, the hemispherical surface, this sphere is surface 2. So can you tell me what is F12? Quickly respond. What will be F12? Will it be less than 0 or less than 1 or equal to 1? Quickly tell me what is F12? Very good, Ravi Teja. Anyone else who can tell me what is F12? Very good, Suman, Rushikesh, it is equal to 1. Why it is equal to 1? Because we know that F11 is a flat surface which is equal to 0. So I can say, applying summation rule, F11 plus F12 is equal to 1. So ultimately your F12 is equal to 1. Because this is equal to 0, so F12 equal to 1. Clear? Clear? Understood? Okay, can you tell me what will be F21? What will be F21? Will it be equal to 0 or F21 less than 1? Less than 1. Option A, option B, which is correct? We're having 2 options, F21 equal to 0, F21 less than 1. Exactly. Very good. It will be less than 1. It won't be 0 because why it is it will be not equal to 1, because some of the radiation will be reaching its own surface. Some of the radiation will be reaching surface 1, but some of the radiation, some of the emissions will be reaching its own surface. So obviously will be equal to F21 less than 1. Clear? Understood? We'll be solving some numericals in today's session so that you have a clear idea. Now, very important, radiation network. In radiation network, there are two terms, which is radiosity and irradiation. Radiosity and irradiation. Normally, radiosity is denoted as J and irradiation denoted as capital G. What is irradiation? Quickly respond. What do you mean by irradiation? What is irradiation? I'm taking one example. From this example, I will be helping you out to understand. If this is a surface, there are 2 rays which is incident on this surface and another one is leaving the surface. So, which is radiosity? A red one or blue one? Which is radiosity? The radiation or emission which is leaving the surface is known as radiosity, and the radiation which is incident on the surface is known as irradiation. Clear? Understood? The radiation which is reaching the surface is known as irradiation, and the radiation which is leaving the surface is known as radiosity. So I can write the relation between the two something like this. The number of emission will be equal to what will be J? If this is a opaque body, because we have studied in the previous class, this is an opaque body. Clear? Having emissivity E. So can you tell me what will be J? Will it be equal to G or some portion of G equal to G? or any property should be multiplied with the factor of G, it will be rho times G plus E. Rho times G plus E. Having any doubt, do let me know. Why I have written as rho into G? Why I have written as rho into G? Because out of this G, only some portion is reflected back. Only some portion is reflected back. So that's why I have written as rho into G. But why I have written E? Can you tell me? Anyone who can explain why I have written E? Saurabh, opaque body is that body in which your transmissivity is equal to 0. That means your radiation cannot bypass through this surface. That is opaque body. Now, why I have written summation? Because only a portion is reflected, so I have written reflectivity into G, but why I have written capital E? Anyone who can explain why I have written capital E? Because if you are able to understand this, then your basic concept is clear. Definitely your basic concept is clear if you are able to understand why I have written this capital E. Quickly tell me. This is understood. A portion will be reflected back. This is rho times G, but why I have written capital E? Anyone who can tell me? Type of object. Okay, anyone answer who can answer me? Black body is a perfect. This is not a black body. This is not a black body. Why? Because I have given this emissivity. This body is having emissivity E. No, Gaurav, you are correct. Black body definition is correct, but I have given this body is having emissivity E. Total emissive power. Very good, Sharmila. This is total emissive power. Why? Because I have said in the previous two classes, if a body is having a finite temperature more than 0 Kelvin, then that body will be emitting some emission. In the previous class, I have told you about the difference between reflection and emission. I hope so you understood this. So this body is having some temperature. So obviously, what will happen? It will also emit some emission. So total will be E plus rho into G, which is J. Clear? Understood? This is the most important concept because many of the students, they neglect this E and they land up with the wrong solution. So your radiosity, the total emission leaving the surface will be the portion which is reflected due to the incident plus the emission which is E. Clear? Now, instead of rho, I can write this is 1 minus alpha. Instead of alpha, I can write this is emissivity by using Kirchhoff's law. By using Kirchhoff's law, I can use directly instead of alpha, I can write emissivity. Previously, we have discussed this. Clear? So we can say the net heat exchange, your net heat exchange will be equal to J minus G into area. J minus G into area. Clear? Understood? Put this value, some of the terms will be cancelling out. So you will be landing up with the term E minus G into 1 minus emissivity into area. We'll be landing up with some of the terms which will be cancelling out. Again, put the value of G in terms of J. When you solve it, you'll be getting, and instead of this E, I can write this as emissivity into EB. I can write this total emissive power in terms of black body emissivity or emissive power. So it will be E minus G, 1 minus E. Rearrange this. EB minus J upon 1 minus E upon E into A. I'm writing over here again. This is EB minus J upon 1 minus emissivity upon emissivity into area. Clear? Now, very important concept is being derived from this heading. Do you remember electrical analogy? Anyone who would remember what is electrical analogy? What is electrical analogy? Anyone? Electrical analogy is basically we are comparing the Ohm's law. We are comparing the Ohm's law with the heat transfer concept. Bhaumik Upadhyay, I will definitely tell you at the end of the session. Please be with me and do remind me about this. M.Tech in heat transfer. Definitely I will tell you about this topic. What is it says? We are comparing the Ohm's law with the heat transfer. So I can write your current, I can write it as change in voltage or resistance. V is equal to IR Ohm's law. Clear? V by R. What I did, I'm comparing the Ohm's law with our heat transfer. So I'm analogy this with the electrical engineering. So your heat transfer, which is current, is equal to the temperature difference upon your total resistance RTH. Clear? Now if I compare these two, this is Q. This is basically, it's a function of temperature only. EB is a function of temperature, J is a function of temperature. So I can relate these two. So what we are landing up is your RTH is basically is this one, and this resistance, very important concept, students, please be attentive. This resistance, which is 1 minus emissivity upon emissivity into area, this is known as surface resistance of the body. Very important, this is known as surface resistance of the body. Clear? 1 minus E upon E into A, this is known as surface resistance of the body. Very, very important. If I want to draw the network diagram, it will be something like this. We are having EB. Just look at this equation. This is EB to J, and the resistance is R, surface resistance. Clear? Any doubt in this? So we are going from EB to J, and we are having this surface resistance 1 minus emissivity upon emissivity into area. Clear? So my next question to all the students is, for black body, what is R surface? Quickly tell me. For black body, what should be the value of surface resistance? Because you know, you have understood what is surface resistance. Now quickly respond, for black body, what will be the value of surface resistance? Because I am going into the basic concepts, then only you will be able to understand this. Clear? What will be surface resistance for a black body? Very good, Gaurav, Rajat and Sharmila. I got 3 response. For black body, your surface resistance will be equal to 0. Why 0? Because emissivity is equal to 1. Emissivity is equal to 1. If you place this value, emissivity is equal to 1. So directly your black body, the surface resistance is equal to 0. Ravi Teja will come after this about the space resistance. Now let us take one more example. By using this example, you can easily relate the for example, this is surface 1, this is surface 2, and from surface 1, for example, J1 into A1 is the total radiation which is leaving surface 1, and out of which only a portion is reaching surface 2, which is J1 A1 F12. Similarly, from surface 2, J2 into A2 is the total radiation leaving surface 2, and out of which J2 A2 into F21 is reaching surface 1. Clear? So Suresh, I will tell you after this. Very good, Gaurav. So what will be net radiation? Net radiation exchange. Net radiation exchange. This will be the difference of these two parameters, which is J1 A1 F12 minus J2 A2 F21. Now, by using reciprocity theorem, your A1 F12 is equal to A2 F21. I can take this as common, so I can write this is J1 minus J2 upon 1 upon A1 F12. Clear? So this is again your, if you apply your electrical analogy, this resistance is basically known as your space resistance. This is known as space resistance. So my question is, my dear students, is there any possibility that your space resistance will be equal to 0? Yes, quickly respond. Is there any possibility, like if you're using two black bodies, will there be any space resistance equal to 0? Saurabh, yes, definitely. Look, understood about the space resistance? If you're taking the black body also, then also we'll be having, very good. If you're taking infinite area, then only you will be getting space resistance approximately equal to 0, which is not possible. So always your space resistance will do exist in all type of surface. Coming back to Saurabh's questions, why black body is not having surface resistance is quite easy. What is surface resistance? Surface resistance is 1 minus E into A. For black body, what is emissivity? Emissivity is equal to 1. If emissivity is equal to 1, put this value over here, then your resistance surface or surface resistance will be equal to 0. Clear, Saurabh? Clear? So this is the two very, very important concept. If you combine, this is about, yes. If you combine the two surface or two plates, there are two plates 1 and 2. So in between this we'll be having one surface resistance at this surface, a space resistance between the two surfaces, and a surface resistance at this surface. So if you draw the network diagram, it will be EB1, it will be EB1, J1, J2, EB2. This is your surface resistance for body 1. This is your space resistance, resistance space, and this is your surface resistance for body 2. Clear? So ultimately, if you are having two plates, parallel plates, so we'll be landing up with 3 resistance, 2 surface resistance and 1 space resistance. Yes, what is your question, Vishwas? About the radiation network. It's very easy. You just have to understand what how many types of resistance are there. If you go with the crisp, in radiation there are 2 resistance, which is a surface resistance, and space resistance. There are 2 resistance which I have taken from the basic. Clear? Surface resistance, space resistance. If there are 2 plates, in between 2 plates we'll be having 2 surface. This is the 2 surfaces, and between 2 surfaces we'll be having a space resistance. And the formula for surface resistance is 1 minus emissivity upon emissivity into area, and space resistance is basically 1 upon A1 into F12, or A2 into F21 is more or less same thing. Clear, Vishwas? So if I take, for example, if I take 3 plates, so can you tell me what will be surface resistance? How many surface resistance? How many surface resistance? And how many space resistance? Quickly tell me. If I am taking 3 plates, there are 3 plates. So how many number of surface resistance will be there, and how many number of space resistance will be there? Quickly respond, because after that we'll be starting off with the radiation shield, which is also very important. If I am taking 3 plates, this is plate 1, this is plate 2, this is plate 3. So can you tell me how many number of surface resistance will be there, and how many number of space resistance will be there? 4 and 2. Okay, let us check, Rajat. Anyone else who can respond? 3 surface and 2 space, Mohammed. Okay, Sharmila, 3 and 2. Okay, anyone from space 2 and surface 3? Okay, very good. Let us check. I am getting good response. Let us check how many surface and how many space. Let us first go for the space resistance, because it is easy to understand about the space resistance. So space is basically in between 1 and 2, there is space 1. This is space 2. So ultimately we'll be having 2 space resistance. This is confirmed. This is confirmed. Let us check the surface resistance. Okay, if you talk about this plate 1, only this side is active, because we are talking about only this side and this side. So this is surface 1, this is surface 2, this is surface 3, and this is surface 4. Clear? So ultimately we are having 4 surface resistance, because for plate 1, if this is my hand and this is plate 1, so only this side will be having the radiation. It is going to this plate. So this is second plate, the first side, second side, and third plate, this is the fourth side. So ultimately we'll be landing with 4 surface resistance. So if I say, if you are having like 10, we're having 10 plates total. So can you tell me how many number of space and surface resistance? In that case, it is very difficult if you're going with a diagram. So for that, there is one shortcut formula which you should know. The surface resistance, the shortcut formula is 2 into n plus 2, and this is n plus 1, where n is the number of plates between the two parallel plates. So if I take this as total number of 10 plates, so we'll be having n will be equal to 8, because 8 plates will be in between the two plates. We can put this n equal to 8. So ultimately it will be 18 surface radiations and 9 space radiations. Clear? Clear? Understood? So this is the shortcut formula for understanding how many number of space radiations and surface radiations can be there. Clear, Paritosh? Okay, next is radiation shield. Very important. Radiation shield is it's also one of the interesting and important topic. For example, we are using two plates. We have used two parallel plates. Okay, and can you tell me how many radiations will be there? I'm using this two plates, plate 1 and plate 2. So tell me how many number of radiations are there? 1, 2, 3. Total radiations if you include both surface and space radiations. Quickly tell me. Yes. Quickly tell me what will be the number of radiations. We'll be having, very good, we'll be having total 3. We'll be having total 3 radiations, out of which 2 will be surface and 1 will be space. Now, what do you mean by radiation shield, or what do you mean by shielding? Can anyone who can tell me what do you mean by shielding? Please tell me what do you mean by shielding? What do you mean by shielding? Because this is a very important topic which you should know. What do you mean by shielding? Shielding is basically if you are inserting a plate in between the two parallel plates, so what will happen? It will reduce the rate of heat transfer between the two plates. Understood? I'm using once again. There are two parallel plates. In between the two parallel plates, we are inserting one plate just like this. If I'm inserting one plate, so what will happen? The rate of heat transfer will decrease. Okay, the rate of heat transfer will decrease. Clear? So if you insert one more plate, so what will happen? Your rate of heat transfer will again go on decreasing. This is known as shielding. Shielding is basically between two parallel plates. If a plate is inserted, so what will happen? It will reduce the rate of heat transfer. That is known as shielding. Shielding is basically your heat transfer is decreasing. Your heat transfer is decreasing. So in order to reduce the rate of heat transfer, your heat transfer rate will decrease. Okay, clear? So if you draw the network diagram for this, if you are using without shielding, if you draw the network diagram, if you write the equation, it will be Q is equal to EB1 minus EB2 upon 1 minus E upon E into A plus 1 upon A into A1 into F12 plus 1 minus emissivity 2 upon emissivity 2 into A. This is applicable for all the equations. This is applicable for all the equations. Clear? Now, if I'm using two plates having same emissivity, if I'm using the two plates having same emissivity E, clear? So some of the terms will be cancelling out. So we'll be landing up with a very basic equation, EB1 minus EB2 upon 2E minus 1. 2E minus 1. Clear? Understood? Let us take this as equation 1. This is without shield. This is without shield. This is without shield. I have used this. Definitely, Nagaraju, I will be taking up this shape factor. I have taken one equation. Clear? Okay, this is without shield. Now, if you insert one plate having the emissivity same emissivity, I'm taking for you for understanding it better. Fine, we have taken emissivity having the same plates. So if the net heat transfer will be EB1 minus EB2 upon, if you write this will be 1 minus E upon E into A plus 1 upon A1 F12 or F13 plus twice 1 minus emissivity into emissivity A, which is for 3, plus 1 upon A3 F32 plus 1 minus emissivity upon emissivity into A2. Clear? So this is the number of resistance which we are having. Now I've taken all the plates having same emissivity. Again, as these are parallel plates which are infinite, so I can take A1 is equal to A2 is equal to A3, and if you write the equation again, this will be EB1 minus EB2 upon 4 upon E minus 2. 4 upon E minus 2. If you see the previous equation, it is EB1 minus EB2 upon 2 upon E minus 5. That means it is 1 by 2 times of this. So I can write this as Q with shield is equal to Q without by 2. Q without by 2. Clear? Fine. This is Q with shield is equal to Q without by 2. Now, by using this, there's one very interesting concept which is being discussed. That is if all the plates are having same emissivity, that means including the shielding plate. If you include the shielding plate also, then there is a shortcut formula which is Q with shield will be equal to Q without shield by N plus 1, where N is number of shield, Clear? Where N is number of shield. Understood? Where N is number of shield, that means if you are using a single sheet, then that will be having a 50% decrease in the rate of heat transfer. So if I want, can you tell me if I want a 80% reduction, if I want 80% reduction in the heat transfer, so how many number of shield will be required? Quickly respond. If I want to have 80% reduction in the rate of heat transfer, so how many number of shields should be inserted between the two parallel plates? How many number of plates should be inserted? Quickly. It will be. This is only applicable for shielding. Oh, the condition is very, very important condition. You can apply this direct formula only if all the plates are having same emissivity. All the plates is having same emissivity. Then only you can use this shortcut direct formula, which is very useful for any competitive exams, either GATE, engineering service, or ISRO or SSC JE, any exam. They will definitely ask one question from this, which is a very time saving and direct formula. The only condition is all the plates should be having same emissivity. Clear? So number of plates should be, quickly tell me, what should be the N value? If you want to have 80% reduction, then N should be 3 or 4 or 5. Okay, Suresh, 3. Anyone else? Because many a times students are not able to understand what is being asked. They are saying 80% reduction is required. That means if you insert one plate, 50% is there. If you insert 4 plates, if you are inserting 4 plates, if your N is equal to 4, then means it is equal to 0.2 times of Q without or with shield, without shield. That means we are having a 80% reduction. We are having 80% reduction. Clear? So if N is equal to 4, then only will be getting 80% reduction, not N equal to 3. If N is equal to 3, then that will be Q by 4, which is 25. That means 75% reduction. If this would happen 75% reduction, then that means your N should be equal to 3. Now you got the concept. If your N is equal to 3, then you will be getting 75% reduction, which is 0.25. because ultimately we are talking about the reduction rate, not the times, which how many times it is without shield. Clear? Understood? This is the main problem the students are facing, because they directly take the value according to this direct value, which is wrong. Clear? Now, yes, what was your doubt, Saurabh? How your n 2n plus 2? Coming back to this. Yes, it's a direct formula. This is being used by permutation combination. Fine. By trial method only this formula has been derived. You can check for any number. You just check for any number. For example, if I take 3, let us take total number of plates are 4. This is 3 and 4. There are 2 plates are there. In this case, n is equal to 2. Put n is equal to 2. Your number of surface resistance will be equal to 6, and this will be equal to 3. You can cross check it. Let us check. This is surface 1, this is 2, 3, 4, 5 and 6. Clear? So total number of surface resistance is 6. Space resistance is 1, 2, 3, which is 3. So this is applicable for all the plates, all the surfaces. But if I talk about the last portion, which is radiation shielding, which is Q by n plus 1, that is only applicable if all the plates are having same emissivity. Clear? If all the plates are having same emissivity, then only this that formula is directly applicable. Understood? Any doubt in this? Because I have given this radiation topic in a very short and crisp manner. So n is number of plates between the two. And I have taken this 4. N is number of shields. This is number of shields. Clear? N is number of shields, not number of plates. Okay, Saurabh, n is not a number of plates, it is number of shield. Angle section, n is number of, not number of plates, Suman, it is number of shield. That means if we are taking 4 plates, so there are 2 plates which is acting as shielding. These 2 plates are acting as shielding between the 2 parallel plates. Your n is equal to 2. Understood? Understood? Any doubt in this till this one? This is the basic of radiation heat. We are having still more concept. Fine. We'll be definitely in the coming up classes, we'll be discussing those concepts. So this is the basic concept which you should know for solving any problem from radiation network, which is very, very important. Now let us solve a few questions so that you can understand how to apply this this concept on this problem. So let us take this one. There are 2 long parallel plates. Now, whenever this term is there, a long term is there, then that means we are talking about infinite long plates. Fine. Then we are talking about infinitely long plate. Shape factor. I have discussed in the starting of this, Saurabh. What is shape factor? Shape factor is basically the fraction of radiation which is leaving surface 1 and reaching surface 2. I have given in the detail. When this video will be over, this live session will be over, then again you can replay this video, and in the starting I have given you in detail what is shape factor and what do you mean by the different theorems. What are the different theorems of shape factor? Now the question is, we are having 2 long parallel plates, fine, each having same emissivity, which is 0.6, maintain at different temperatures. If it is desired to get 80% reduction, so can you tell me how many number of shape resistance will be there and surface resistance will be there? Quickly tell me. Options A, B, C and D. Very good, Rajat. It's very easy. Just now I have taken this example. If you want to have 80% reduction, first of all tell me how many number of plates should be there, or how many number of shields should be there. Look, they are asking space and surface. First space, second surface. Very good, Suresh and Balaji. What about the rest of the students? Please respond so that we can solve many problems. Don't stuck on this simpler problem. Now, I'll be giving you 2 methods to solve this. One will be taking less than 5 seconds to solve, and second will be taking around 40 seconds to solve. Let us try the first conventional method, then I will talking about the easier method. Clear? Now, for getting 80% reduction, for 80% reduction, clear? So Q is equal to Q without or with shield is equal to Q without shield upon n plus 1. N is number of shield. Now we need to get 80% reduction. That means your n should be equal to 4. So this will be 0.2. So this means your 80% reduction. So if n is equal to 4, what is surface resistance? Surface resistance will be equal to 2n plus 2, which is 10, and space resistance will be n plus 1, which is 5, which is option A, because they are asking space relation at the first and second as the surface resistance. The shortcut method, look, never ever both space relations and surface relations can be equal, so directly you can eliminate this C, D. And the second most important is never ever your space relation will be greater than surface resistance. This also will be eliminated, so option A is the right answer. Fine. So by looking at the option also, you can directly mark the answer. For that, you should know what is the basic concept behind that, then only you can eliminate the option. Look, never ever space and surface resistance will be equal, so directly a C, D option is eliminated. Also, your space resistance cannot be greater than the surface resistance. This is also cancelled out. So option A, we are left with this option A. Clear? Because always all the students do know the concept, but the time is also a very important constraint. So you should increase the accuracy and also you should know what are the shortcut methods, which is very helpful for all the students, those who are appearing for the different competitive exams. Clear? Because at this stage, at this point of time, because you might be in the third year or final year, or we can say pass out also, you should be knowing at least the back of the mind what is a shortcut method. Okay, very good, Suresh. Let us take the next question. Okay, again, two long parallel plates having emissivity 0.6 is maintained at 227 degrees Celsius and 1227 degrees Celsius respectively. A polished aluminium shield is having emissivity 0.05 is being inserted between the two plates. What should be the temperature? What is the temperature of the shield? Saurabh, yes, this is applicable to all the cases. Which one? N plus 1. N plus 1 is not applicable for all the cases. Look, I am repeating once again this formula. I am highlighting it with this black marker. This formula, the surface relation spacing, it is applicable for all the surface. And this formula, which is Q with shield is equal to Q without shield by N plus 1, this is only applicable if your emissivity of all the plates, including the shield, should be equal. Clear? This is the criteria. Let us take this one. We are having two plates. Let me draw the diagram so that you can understand it easily. This is 1227 degrees Celsius. This is 227 degrees Celsius. This is emissivity 0.6, shield having 0.05. Now, if you are in this case, you won't be applying the direct formula, because in this case the plates and the shield are not having the same emissivity, so direct formula is not applicable. They're asking what is the temperature of this plate in degrees Celsius. Clear? Now, the most important thing which you should remember always in radiation topic, you should convert the unit of temperature from degrees Celsius to Kelvin, then only proceed with the solution. Clear? The first step in heat transfer, in radiation heat transfer, is you should always convert the unit to Kelvin. Okay, so many of the students got the answer. So let me convert this. This will be, if you plus 273, this will be 1500. This will be 1500 degrees Celsius, 1500 Kelvin, and this will be 500 Kelvin. So many students got the answer. Let us see they are having correct answer or not. Okay, many students got A. Let us check whether they are correct or not. Fine. Many of the students got A. Let us check whether they are. Look, direct formula. I am giving you a direct formula how to solve this type of problem. Just see 1500, or just write the equation between plate 1. I'm taking the next. Okay. You can write this plate as 1, this is 2, this is 3. So EB1 minus EB2 upon 1 minus E1 upon E1A plus 1 upon F12 A1 plus 1 minus E2 upon E2 into A2. Clear? Should be equal to, because these are in series connection, so heat transfer between 1 to 2 should be equal to 2 to 3. So this will be equal to EB2 minus EB3 upon 1 minus E2 upon E2 into A plus 1 upon A2 F23 plus 1 minus E3 upon E3 into A. Now you might be thinking how to solve a so complicated equation in a very short time. So let me give you one shortcut method for this question also. Look, the question was something like this. You have to calculate the T. This is 1500. This is 500. This is 0.6 emissivity, 0.6. And I hope so this was 0.05. Okay. So 0.05. Clear? So the shortcut method is just try to write these two equations equated with this. So this will be, look, if you talk the previous equation, this EB can be written as using a Stephen-Boltzmann sigma into T to power 4. Clear? I am writing the direct formula so that your time is saved. So I can write this as between 1 and 2, this is plate 1, this is 2 and this is 3. So T1 power 4 minus T2 power 4 upon, area is cancelled out because this is a long plate, so area will be cancelling out. So it is 1 minus E upon E into A plus 1 minus E2 upon E2 into A, because this is same, I can take this area equal to 1, this is A into F12, this is also equal to 1, is equal to T2 power 4 minus T3 power 4 upon 1 minus E2 upon E2 into A plus 1 upon A F23 plus 1 minus E upon E into A. Now you can see both the denominators are same. Please check whether these denominators are same or not. I am repeating once again, whether these two denominators are same or not. Please respond quickly. Whether these denominators are same or not, because emissivity of this plate and plate 3 is same. This is same. Areas is also same because this is long parallel plate, so I can take area for all the plates equal to 1, and also this is infinitely plate, so all the radiation will be reaching the other plates. So ultimately these two terms will be directly cancelling out. This two term will be directly cancelling out. Yes, Saurabh, what is your doubt? How these two are not equal? This is equal. Look, these two terms are same. This is equal to 1, this is equal, this is also equal. So all the terms are equal. Fine. So everything will be cancelled out. So only left with T1 is 1500 4 minus T2 4 is equal to T2 4 minus 500 minus 500 power 4. So ultimately this is T2 is equal to 1500 power 4 plus 500 power 4 upon 2 power 1 by 4. Power 1 by 4. Clear? So if you solve it, you will be getting 1257. You will be getting 1257. Clear? When you solve it, you will be getting, if you go back, you will be getting 1257 Kelvin. So is this correct answer? Is option A correct or not? Quickly tell me. I am getting T2 is equal to 1257 Kelvin. So my question is, yes, definitely Suresh, I hope so. He is confused with 0.05 and 6. Clear? So tell me whether this T2 an option is correct or not. It is not correct. Please read the question carefully. They are asking the temperature in degrees Celsius. but you have calculated in Kelvin. So those who marked option A will be landing up with a negative marking. Clear? Understood? This is in Kelvin. They are asking in degree Celsius. So minus 273, your answer will be option C, 984. Understood? Because this is a question which is very tricky. Because usually, like if I say 80% of the students, they land up with option A, because they will be seeing, okay, my option is in the option, my 1257 is getting in the option. So in a hurry, they mark option A, which is completely wrong. Clear? Read the question twice or thrice if you are not able to understand. Clear? So what I do is, whenever I get a question, if they're asking in the question like in degree Celsius, I highlight that portion so that when I'm solving, I'm getting the answer, it will be having some, yes. What is your doubt, Suresh? If the question is mentioned that polysurface is placed in between and even if the emissivity is different, so then two denominator will be cut out? Yes, very good. They are saying, Suresh is saying like E3 is not equal to E1. In that case, it won't be cancelling out. Okay, Suresh, if your E3 is not equal to E1, in that case, you won't be having these two terms same, so it won't be cancelling out. So in that case, your problem will be very lengthy. Then that type of question is being asked in engineering service conventional paper. Fine. If you talk about GATE point of view or ISRO point of view, they are asking some tricky. This is you can expect this type of question in ISRO. Clear? Or SSC JE, because this is a very easy problem where calculations or less calculation. In GATE also you can expect this problem. Fine. Because if you are having the concept, you can save time and you can increase your, you can give some time to the more difficult question. This is very easy problem. Understood? If you are having different emissivity, then that question will be very lengthy, and that type of question is being asked in engineering service conventional paper, not in GATE, if you are having this much of complications. But if a student don't know, they only know the formula, if he apply the formula, then it will be very lengthy process. Instead of a minute to solve, you will be taking 5 minutes to solve this problem. Because if you are getting this value, it will take some time. Then again you will take this value, put in the calci, you will be consuming some time. Instead of that, please use your brain, use the concept, because act smart, then only you will be cracking the competitive exam. Only knowledge is not required. Along with the knowledge, you should be having the smart techniques, then only you will be cracking any exam. Without calci, we can say we have to round off the figures. Okay, Mohammed. If you are not using calci, then you have to say permutation. You can round off, like you can take the zeros outside. Clear? You can take the zeros outside, only 15 power 4 and 5 power 4, which is easy to calculate. Fine. If you're not having calci, so what you can do, you can remove this zeros, you can take this as common. So only we're left with 15 power 4 and 5 power 4, which is easy for calculation. Clear? Understood, Mohammed? If you want to solve this without calci, take 100 common, 100 power 4 common, only we're left with 15 power 4 and 5 power 4, which is easier for calculation rather than going for 1500 power 4. And take 1/4. So ultimately 100 will be outside, and you can get an approximation value. You have to do some approximation if you're going for without calci. And if you're going for calci, then you can directly get the answer, which is option C, 984 degrees Celsius, not Kelvin. Okay. One more question. Now this question is from shape factor. A solid cylinder surface 2 is located at the center of hollow sphere. The diameter of the sphere is 1 meter, while the cylinder has a diameter and length, like both the diameter and length are equal, which is 0.5 meter. So what they're asking, what is F11? Let me help you out with the diagram. We're having a sphere, and in the center of the sphere we are having a solid cylinder, something like this. This is a solid cylinder which is at the center of the sphere. This is surface 1. This is surface 2. So this solid surface, the complete surface is surface 1, and the surface 2. What they're asking, what is F11? What is F11? What is F11? What will be the shape factor of body 1 with respect to its 1? Hint is use reciprocity theorem so that it is easier to solve it. quickly solve it because this is a very easy problem. Option B. Okay, very good. Anyone else who can who's getting the answer? Okay, let us solve it. What will be F 2 what will be F22? Look, I can directly say F21 is equal to 1, F12 is equal to A2 upon A1 into F21. What is area 2? Sorry. Let me, what will be F? What will be F11? Oh, this is surface 2. Sorry, this is surface 2 and this is surface 1. Because F22 will be equal, F11 equal to 0. Yes, yes, just change this. Solid cylinder is surface 2 and this is surface 1. Very good. Those who responded 1, those who responded 0, they are very good. They're correct. Very good. Those responded 0. So I was like, yes, yes, very good. Now, what is F22? What will be F22? F22 will be equal to 0 because it's a flat surface. Flat, we can say, never ever the second surface will be reaching its own surface. So F22 will be equal to 0. So F21 is equal to 1. F21 is equal to 1. Clear? So how to get F11? So for F11 you should be getting F12. F12 is equal to A2 by A1. A2 by A1 into F21, which is equal to 1. What is area 2? Area 2, what will be area 2? What is area 2? Pi RL or any other surface need to be added on. Because many a times students are not taking these two surfaces also. So area 2 will be, if you write over here, area 2 is basically pi RL, pi, if I take the radius of the smaller cylinder as R into L plus 2 pi R square. Why? Because this is pi R square 2 times upon area 1 is 4 pi capital R square. Capital R square, where small r is equal to L is equal to your diameter length is same, so that means your L is equal to 0.5, small r is equal to 0.25 and capital R is equal to 0.5. Place this, you'll be getting, this is F21, so F12, this is F12, so F12 will be 0.375. 0.375. So F11 will be equal to 1 minus F12, which is 0.625. Option B is the correct answer. Yes, what is your question, Balaji? If both are in same shape or both shape, we choose surface area. Ideal, yes. What is your doubt, Balaji? If both are in the same shape, like what is the question? I didn't got your question. Same shape means area, please explain. Definitely I will be explaining once again. Look, let me take up with Saurabh's doubt. Look, this surface 2 is exposed to this surface. What is the area of this surface? Which is pi RL. pi r L, and also this surface which is shaded, which is pi r square 2 times. Clear? So if I write this area 2, if I write area 2, it will be first this surface, the cylindrical surface, which is pi into r into L, plus the bottom surface which is pi r square, again the top surface which is again pi r square. So ultimately I have written it as pi r L plus 2 pi r square. 2 pi r L, 2 pi r into L, not pi r L. Yes, pi dl. I was confused with the d. So it is 2 pi r into L plus 2 pi r square upon 4 pi r square. Some of the parameters will be cancelling out. We can cancel the pi term. Area 1 is area of sphere, which is 4 pi capital R square. Clear? Understood? If we use surface area but different shape, we use total surface area. Look, Balaji, it depends upon which surface, which area is being exposed. Okay. If you say, if you're taking a hemisphere, for example, if you're taking a surface like this hemisphere, this is surface 1 and this is surface 2. Clear? So can you tell me what will be F 2 1 quickly? If what will be F2 1? If you're having a hemispherical surface, the bottom is flat plate, what will be F2 1? So how to proceed? F11 is equal to 0, F12 is equal to 1, so F21 is equal to A1 by A2 into F12, which is 1. A1 will be pi r square, your A1 will be pi r square and A2 will be 2 pi r square, it then will be cancelling out. Clear? So this is very easy. A1 is pi r square, this is 2 pi r square, which is 1 by 2. That means 50% of the radiation will be reaching surface, will leave surface 2 and reach surface 1. Next class tomorrow will be, every day we'll be having the class from Monday to Friday. We'll be having everyday class at 8 o'clock. Okay. So please be active so that you can gain as many concept as you can from all the topics. Like we'll be covering almost 30% of the syllabus will be covered. On everyday classes we'll be taking some of the topics and that topic will be completely covered. Fine. I'll be trying to get more questions in the next session. Clear? So this were the 3 questions which I felt you need to be understand. This is about the green card. I hope so you know about this green card. Saurabh, definitely I will be taking a session on queen theory. No problem. I've noted down this point and taking the queen theory. Clear? About the green card is basically this is an access to all the questions. We can say you can have an access to many questions so that you can apply this concept, because like for example you have studied 3 days, past 3 days you have studied the radiation heat transfer. Now at this point of time you should be applying your concept which you have studied on the different question. For that green card is a very good access where you can get through the different topics. Like there are 24 subject tests which you need to understand, you need to solve the problems, and there are 12 plus mock tests in which 120 plus questions is being discussed. So you can have an idea and you can apply your concept in these questions, because in every session I used to say the more the question you solve, the more the confidence you will be gaining in that topic. So it's very, very important that you should be having we can say a treasure of questions. So basically this green card is a treasure of questions where you can solve as many number of questions as you can. Okay, so this is about the green card. So thanks for being with me in this session, for being with the Gradeup. And in the upcoming classes we'll be taking up many questions and many topics which is very important every exam point of view. Yes, I can take your doubts. What is your doubt, Gaurav? I have some points on Gradeup app. Yes, definitely you can use these points. It's a very good thing. If you are new to the Gradeup, you will be having some points. You can apply those points, and the price which is shown over here, it will be definitely reducing. Yes, what is the doubt? Are you only take the class, sir, or anyone take the class? Which topic, Mohammed? Definitely, you just give me the topic. Clear? If it is in my expertise, definitely I'll be taking the topic. Theory of machine, in future I'll be taking the classes of theory of machine also, and vibration, definitely Suresh I'll be taking, because vibration is a very important topic if I talk about IES point of view. Engineering Service point of view. At this point of time, if you're going for GATE 2021, you should also aim for ESC, because this series which we have launched is for dedicatedly for GATE 2021 and ESC aspirants. Clear? So this is about the green card. And about Gradeup, prep smart, score better with Gradeup, improve your concept, get your doubts clear with the live class which we are having. Also take class on fluid mechanics. Definitely we'll be taking up the classes, either me or other faculty will be taking up the class of the fluid mechanics. Okay, we'll be covering, definitely we'll be covering Gaurav. I will be covering all the subjects which you feel, because in the comment section you can, those who are at the YouTube, you can comment the topics which you need to be revised again and again. Okay, any other subject by in this week, definitely will be having by Rahul sir or Vikas sir, either one of the faculty will be taking one of the topic, fine, which is relevant for you. Industrial also, either Rahul sir or me, anyone who if you're having a slots, will be definitely taking up with the industrial, most probably this week only. We're planning on that. Saurabh, power plant also, I'm giving you yes, Shrikant, due to the shortage of time I was not able to take the questions, but in the next session, whenever I'll get in the next session, I'll be taking a session dedicatedly for the questions of all the radiation topic. Fine, I'll be covering all the radiation and I'll be taking around 10 to 15 questions, so that you can apply those concepts. We'll be solving some live questions. This was only 3 questions, which is a sample for you so that you can apply. Sure, definitely Suresh, if possible we can take that vibration section the last week. Okay, so thank you. Do subscribe this channel so that whenever we are having live sessions, you will be getting the notification. You can have the live session notification being pop up. So all the best for your exam, and please prepare well and stay safe and healthy. Thank you once again. This is Sooraj from Gradeup. So all the best for your exam. Thank you.